So, welcome to our presentation as part of the Project Hack 23. This is challenge 4, and the demand scenario planning team is modeling Mayhem, and it's Project Hack 23. So, modeling Mayhem is comprised of 7 team members: myself, Matt Wells, Liam Gregson, Charlie Butt, Annabelle Douglas, Kelly Lever, David Belshaw, and Archana Walker. So the challenge summary: heads of planning need an efficient way to assess the impact of changes in demand and key business metrics. This helps them develop and validate strategies that optimize delivering cost, forecast across the entire product portfolio using accurate assumptions and data, provide concise summaries suitable for management without requiring extensive processing, and identify risk, constraints and opportunities for meeting cost delivery objectives, and summarising demand scenarios. It's essential to tailor the level of detail based on forecast confidence and ensure that scenarios can be easily adjusted for dynamic what-if analysis. So part of our product development solution was 2 elements to this. We used the Microsoft Power Apps tool as a development for loading demand, and dashboard development using Power BI, using the visualizing the current footprint of data and exploiting what-if scenarios in this tool. Visual mapping.
Yes, we use the Miro visual mapping tool to map the key areas our product and solution adds value in. Primarily, it allows the business to optimize its resources in terms of volumes, factory hours, and ultimately cost. It helps drive data maturity. It's a scalable product with lots of areas for future improvement, and it helps us to inform our internal customers on areas of demand and capacity under or oversupply, and also helps us to inform external customers of possible future delays.
This is the design concept, and you can see a schematic of the output. So the current data extraction using SAP. We use the Power BI dashboard as a tool to view the data and run what-if scenarios, and the Power Apps to load demand iterations. Solution.
Yep, this is the dashboard that we ended up creating in Power BI. We called it the Super Modeler 5000. If you look on the left hand side, on the left visual, you'll see how we've visualized the footprint output from SAP. So we have the demand loaded against the month offset, and on the right hand side of the left hand visual, you can see the cumulative volume, hours and spend over time. All of this is filterable by the filter panel at the top, so business area and by demand grouping, and essentially it gives us a view of what our current plan is at the minute. The second slide, so part 1B, is the what-if scenarios. So on the left hand side, you'll see the current plan again, and you'll see the original volume and the adjusted volume. We set them capacity to maximum, so essentially it's running an unrestrained plan, and essentially all of the demand it's saying we can meet, and then we are restraining the capacity on the right hand visual, so we've set the volume to 53, and then that's showing the impact of the plan. So you can see the light blue bars is now shrunk, and that's because the demand has had to be spread over different multiple months because of the capacity constraint that we've set. The future plans for this, if we had more time, was to also constrain by hours and spend, and the long-term goal for the dashboard was to have API connectivity. So essentially we can optimize a plan, export it, and then feed that back into the SAP via an API.
And part 2 of the product solution is to utilize the Power Apps app, which we would use to input the data and use an iterative process once it's viewed in Power BI in the dashboards. Key stakeholders include the heads of planning, who will be looking at this data along with business area leads. We need to make strategic decisions based on the data. Also involves manufacturing, procurement, and other stakeholders. Future applications are considered in the Mira software. So on to the judges' questions.
The first question we had was around the environmental and software restrictions that we faced and how our solution would have changed if we were unrestricted. So we all unfortunately had security restrictions on our laptops, which restricted the software we could use. We would have liked to have access to a cloud environment and to be able to use Python and Mendix. Python to allow us to use more advanced methods of building what if data scenarios than Power BI allows, unfortunately. And we would have liked to have used Mendix to build the demand loading form in rather than the solution that we used of Power Apps.
Second question is, are the additional data sets you believe could enhance the accuracy of your forecast, and where could you obtain these data sets from? Well, if we use actualized figures based on historical data, for example, factory hours, this would help with the accuracy of the data. If we're able to look at multiple footprints and get a wider data set, it would also improve the data we could use for the what-if scenarios. And question 3, reflecting on your development process, what are the most significant challenges you encountered and what lessons have you learned? We would like to be more familiar with the software that we were using. We were learning that on the day. In terms of the Power BI tool and building what-if scenarios, we pivoted our approach later on in the task, and we'd like to have done this sooner with hindsight. We haven't built what-if data modeling scenarios before, but we build on the approaches taken in the hackathon and continue to improve on that going forward. Thank you very much. That completes our presentation.